Short little video on remembering nomenclature. Recall a binary compound contains two different atoms. In this picture, I've got one of two different types of atoms. Same thing with this picture. This is binary. I know there's three kinds of atoms here. Well, two different kinds of atoms, but there's three total. But it's still binary because there's only two different types of atoms. There's one red one and one black one. Doesn't matter that there's two of the red ones. This one is not binary because it contains three different atoms. So we won't be dealing with those. That one is not binary. We're going to start by looking at type 1 and type 2 binary ionic compounds. A type 1, the charge never changes. That's what we're going to look at with the ones in the yellow first. Then we're going to look at type 2 in the green, whose charges do change. They have what is called a variable charge. Just to refresh your memory, for metals, recall that everything in column 1 is a +1 charge. Column 2 is +2. Aluminum, gallium, and indium are +3. Zinc is +2, and silver is +1. To write the name of a binary ionic compound, type 1, the first thing that you need to do is name the cation. So in this case, sodium. Easy enough. And because sodium is a type 1, its charge doesn't change. We don't need to do anything else except write the name of the anion, changing the ending to "ide." Chloride. Sodium chloride. All right, well, that takes care of how to name a type 1. Now we're ready to talk about type 2 compounds, not including silver, zinc, aluminum, gallium, and indium, because those are type 1s. For a type 2, again, you want to name the cation. So in this case, the cation is iron. Then we need to find the charge on the cation, and I'm going to go into that in detail again. But to find the charge, you have to look at the anion. So phosphorus always has a -3 charge. And because phosphorus always has a -3 charge, -3, and we know these compounds always add up to 0, that means iron has to have a +3 charge. So iron 3, and then we're just going to name the anion, changing the ending to "ide." Phosphide, iron 3 phosphide. Remember this absolute rule. An ionic compound's charge will always add up to 0. So let's take a look at sodium chloride. Sodium has a +1 charge. Chlorine has a -1 charge. And because there's one of each one of those, 1 times 1 is 1, we add it up, we end up with a 0. There's two ways we can learn to write the formula of a type 1. And the first way is, first, we simply have to identify the ions. So here we have the calcium ion and then the chlorine ion. Then the second step that we're going to do is called drop and swap. Drop means our superscripts, our charges, are going to be dropped to subscripts. So calcium, we bring the 2 down and the chlorine down. The second step is swap. We're going to exchange those numbers. So the 1 here on chlorine went there, and the 2 here went there. Now, we're going to ignore the 1s because we don't put 1s in formulas, and just write the formula, calcium chloride. The better way to write them is what I call the chemistry method. And since you guys are in AP, you should probably write your formulas this way. You're going to start off again by writing the ions, calcium and chloride. Now you want to add the coefficients so that add coefficients in to this equation so that the charges add up to 0. And you get that by finding the least common multiple. And the least common multiple between 2 and 1 is 2. So 1 times 2 is 2, and 2 times 1 is 1. Now we're going to put in some chemistry symbols. And then we're going to write the formula using these coefficients, this coefficient and this coefficient, as our subscripts. So Ca1Cl2. We're going to ignore the 1s and end up with calcium chloride CaCl2. For covalent compounds, you do need to know these Greek prefixes. See if you can remember them as we go through them. Yes, 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 penta, 6 hexa, 7 is hepta, 8 octa, 9 nona, and 10 deca. Remember, we never use mono for the first element. So here we have CO2, so there's only one carbon, but I'm just going to write carbon. And then carbon dioxide, because there's 2 oxygens. For the second one, carbon monoxide. We never use mono for the first one, but we do use it for the second. For our purposes, we're going to look at acids as having a hydrogen ion attached to an anion. In this case, we have hydrogen attached to this anion, nitrate. An acid can only be an acid if it's been dissolved in water. This is hydrogen chloride, solid hydrogen chloride. But when we add it in the water, we end up with hydrochloric acid. If you recall, there's 2 types of acids, those without oxygen in the formula and those with oxygen in the formula. And of course, they have 2 different sets of rules. So those without oxygen in the formula follow these rules. And basically, these rules boil down to, they're going to start with hydro, and it's going to end with ic. Now, acids that do have an oxygen in the name follow a different set of rules. The first one is we never use hydro, and we're going to change the ending based on the polyatomic. So the polyatomic, if the polyatomic ends in 8, 8 will go to ic. If the polyatomic ends in ite, then ite goes to us. Up next, new chapter, chapter 3, stoichiometry.